Welcome back, trio. Here we are today. We're going to go over the chain rule and we're going to try to differentiate some problems. Here we're going to differentiate this because we have the quantity inside the parentheses raised to a power. We need to use the chain rule. And so let's go over what the chain rule looks like. If I put the formula here, f of g of x, oops, this one should be bigger. This is, we have a composite function, and if we take the derivative of that, then we would get f prime of g of x times g prime of x. So given this function, the derivative of it is this. This is how you use the chain rule. So now we're going to use that chain rule with this problem. So to do that, let's go over it. Come on in. We have to do the outside function first. So looking at the outside function, we take this down, rewrite the inside, change the exponent by subtracting 1. So that's the derivative of the outside. Now we have to times it by the derivative of the inside. Again, we're going to take the derivative of this one, move this one down. 2 times 3 gives us a 6. Subtract 1 from the 2, that gives us a 1, which is just invisible. The derivative of 5 is 0. Simplify this. Six x plus 0 is just 6x. Simplify a little bit more, take this, multiply to this, and that gives us 18x times the quantity 3x squared plus 5 squared. That's the answer. And I'll be back with another example. Welcome back, trio. Here we are, we're differentiating this. We need to differentiate this. We're going to use the chain rule. This is the chain rule. This is our second example in this video. But this one actually needs to use the chain rule and the product rule. So let's go over the product rule. If I have f times g, or let me say f of x times g of x, and I want to take the derivative of that in terms of x, then we would get f prime of x times g of x plus g prime of x times f of x. That's the product rule, and we're going to use that here. So that means first thing we need to do is take the derivative of this one times this one plus the derivative of this one times this one. Okay, so we can do this. Take the derivative of this one, that gives us just 2 times this. Again, This one, the derivative of x is 1 times 2 is just 2. The derivative of negative 3 is 0. It's gone. And we just bring this one down. Now we got to take the derivative of this one, which we need to use the chain rule. So let's do that. We bring the 4 down. And that's going to be x squared minus 5. Subtract 1 from the 4, that makes us a 3. Times the inside, so we have to say this is going to be 2x. The derivative of 5 is 0, so it's gone. And then we have to bring this one down. 2x minus 3. Now, we did the derivative, but now we should simplify. So this one stays 2 times x squared minus 5 to the 4 plus 4 times 2 gives us 8. So we have 8x times 2x minus 3 times the quantity x squared minus 5 cubed, and we are done. That's the answer, and I'll be back with one more example. Welcome back, trio. Here we are again using the chain rule to differentiate this. We're going to need to know the derivative of sine, and I'll go over that in a second. And here we go. So the derivative of sine is cosine. So derivative of sine is cosine. So now we're going to use that fact to use the chain rule here. So d dx of sine x plus 1 gives us cosine of x plus 1. But we also have to take the derivative of the inside. Derivative of x is just 1. Derivative of 1 is 0. Simplify that, we get cosine of x plus 1 times 1. Anything times 1 is itself. And we are done. Thank you. Go Trio.